Welcome back. I'm Chris with LaunchCode. This final video in our first persistence lesson will connect all of the dots and we'll see our application data actually stored in a MySQL database. The first two videos have been just configuring our database and application settings and then our classes respectively to interact with the MySQL database, but our controller code doesn't actually use any of that code yet. So in the last video, we created this event repository interface, and I told you that this was going to be the type that we used to interact with our database. But if we go to our controllers on the left, let me expand the controllers package and go into event controller. I don't have an event repository anywhere in here. In fact, I'm using this static event data class to sort of temporarily keep all of my event objects in an in-memory data structure. So in this lesson, we're going to refactor the controller so that it can use our event repository in order to insert and retrieve objects from our database. So the first thing I'm going to do is I'm going to make sure that this repository is available in my controller class. So at the top, let me just put this code in here, then this warrants quite a bit of explanation. So just hang on with me for a second. So the first thing I'm going to do is make a private event repository called event repository. And then above that declaration, I'm going to use the annotation auto-wired. Okay. So what's going on here? A couple of new things. One is that this auto-wired annotation specifies that that Spring Boot should auto-populate this field. We're not going to create a constructor to assign a value to this event repository field. We're not going to add a setter. We're not going to do anything like that to automatically assign a value to this event repository field because we want Spring to manage this class for us and to manage this field for us. So this is a feature of Spring Boot that's widely used and is pretty complicated to understand at first. And so just to be honest, we're going to sort of wave our hands a little bit at it, but I want to tell you what it's called and just make you aware of what's going on. And if you want to learn about it more on your own, you can do so later. This is using a feature of Spring called dependency injection. Another term for dependency injection is inversion of control. And I'll admit both of those terms sound pretty scary. When I first learned about dependency injection, I was like, what is this thing and what's it doing? It seems magical and I don't understand it and I don't want to use it. However, if you sort of just get comfortable using dependency injection, it quickly becomes intuitive, even though the underlying mechanisms that make it work can be pretty complicated. So what is actually going on? So what happens is that this code, this auto-wired code, basically tells Spring Boot, it says, hey, Spring Boot, I need an event repository object. Do you have one for me? And so if Spring Boot, when it looks at this class, it'll see the auto-wired and it'll look around within its application and say, hey, do I have any event repository objects laying around that I can put inside of this field? If it does have such an object, it'll put it into this field and then our code will be able to use it. If it does not have an event repository object, it'll throw an exception and your application will be basically useless at that point. So how does Spring Boot itself obtain an instance of event repository? We said this will be set as long as Spring Boot has an event repository object laying around. Well, if we go back to our event repository class, adding this at repository annotation flags to Spring Boot that this is a class that it should manage for us. It says, hey, Spring Boot, this class, I want to make it available for other parts of my application just so they can use it if they want to. Can you please manage this class for me? Can you create an instance of this class and just leave one hanging around in case anybody else needs one? And so that's essentially what's happening. By putting this at repository annotation, this is one of the things that annotation does, one of the many things it does. But at a bare minimum, it flags to Spring Boot that this is a class that should be managed, that Spring Boot should create event repository instances and then inject them wherever our code asks for them. And one way to ask for such an object is by using auto-wired. So the auto-wired annotation basically says that this field will be automatically wired up with an actual object. Now there's one more thing I want to talk about before we move on and start using this, which is that, again, sharp Java developers would have already seen this, but this is an interface, okay? This is an interface. And then I'm going to use an instance of this interface over here. Now, using an instance of an interface, there's nothing wrong with this. We talked about coding to interfaces as being a best practice, that you want to use interface types whenever defining fields or local variables whenever possible. That's a great thing to do. However, an interface, you cannot actually create an object from an interface class. I can't call a constructor on event repository. In fact, there's no actual code in this class. I can't create an explicit event repository concrete instance. I have to have a class that implements this interface. Remember that an interface is a blueprint and says, any class that implements this interface must follow the following rules, must provide the following fields. We learned about interfaces earlier. And so it's essentially a contract. And we have to have a concrete class that implements every interface we want to use. And our code doesn't actually have a concrete class that implements event repository. In other words, there's no other code in my application that says something like public class my repository implements event repository. Remember, this is the kind of thing you would have done earlier when you were, looking at the interfaces chapter of the class. We don't have a class anywhere in our application that does this. So how in the world will we end up with an object of event repository type if there's never a class that implements that interface? That's a good question. And so the answer to that question is a little bit unsatisfying for new developers perhaps, but this is, again, something that Spring Boot does. It's very, very powerful for us. So this CRUD repository interface, which I'll dig into a little bit deeper in a moment, is a special interface, and it essentially allows our code to store and retrieve object instances from a database of a specific type. In this case, we're storing and retrieving event object instances. And a lot of that code is pretty boilerplate. So it would say, a common thing you want to do is, get a single object, or get all of the objects, or delete an object, or create a new object and save it in the database. All those things are pretty boilerplate. And so in fact, since that code is so boilerplate and so consistent, every CRUD repository we do have in our application would look very, very similar in terms of the actual code that would be inside the class. So since it's so boilerplate, Spring is actually able to create these classes for us. So when the application starts up, Spring Boot will see this event repository interface, and it will, in memory, on the fly, and this is where things get kind of crazy, on the fly, it will create a class just like this one, public class my repository implements event repository. It'll create a class like that in the application's memory, and then it will make sure that that class can be auto-wired into this field. Okay, so Java actually has the ability to create classes on the fly. So an application, when it's running, can create new classes. You can of course create classes by writing code in a file, in a Java file, but Java code can actually create classes in memory itself, and that's exactly what's going on here. So again, sort of confusing, but once you start using it, you will quickly get used to this. So let's go show you what you get by using a CRUD repository. So I'm going to go to my browser, and I'm going to search for CRUD repository JavaDoc. JavaDoc is just a term I throw on the end of any sort of search when I'm looking for documentation for a specific Java class. Okay, 223. Let's go to the most recent version, which is probably the version we're using. And we've looked at JavaDocs before. They're pretty complicated. They have a lot of sort of jargony stuff in here, a lot of text that can be hard to read, but they also are the most concise and immediate place to find the stuff you need. So this interface, it extends the repository interface, which is the base class for CRUD repository. Remember, CRUD just stands for create, read, update, delete. It's sort of the acronym for the basic things you can do with a relational database. And if we go down below and look at the methods that are in this interface, we see that there are methods that are pretty easy to understand. So this repository provides us with a count method. This will return the number of entities available. In other words, how many events are in our database. It will delete an entity for us. It will delete everything for us. Just to go down below, find all. This will return all of the event objects in the database. So we'll be using this one very shortly. Save. This will insert a new entry in the database. Find by ID. That will find a specific object based on its ID or its primary key. So these are all things that aside from the method names, they're exact same things you've been doing with your SQL queries. And this is what I meant by boilerplate. Every single repository that we create will need this basic behavior, and that's why Spring Boot went to the trouble of making it so we didn't have to implement this interface ourselves. It's going to be able to do it just because it knows so much about databases and how to store and retrieve objects from them. Okay, so there are a lot of other, just one note before we start writing code, there's a lot of other repository interfaces. So this is the base repository interface. There's the CRUD repository. There's something called paging and sorting repository, reactive CRUD repository. There's a lot of these, and these all have slightly different functionality. Most of them will have just the basic read-write functionality, but if you need to do something special with your database, you might look into what other repository interfaces are available to allow you to do that. All right, let's close the browser, go back to our code, and I'm just going to start writing code to use our event repository field. So in particular, we talked about, let me just make a comment here just for notes. We saw three methods that we want to use. We want to use find all, we want to use save, and we want to use find by ID. We might end up using this one, but I'll put it here for now. So these are just to remind you, these are methods that are part of this interface because this interface extends CRUD repository, event repository gets them too. They're all methods that are part of this interface that we have available to our use, even though they aren't in our interface itself because they're part of the base class. So let's go in here, and essentially what I want to do is any place that I see event data, I want to go ahead and replace that usage with something that uses my event repository class. So a good handy IntelliJ tool to use is the follows. So if I go to event data, let me right click on that class right there, and let me go to find usages. This is about a third of the way down from the context menu. I click on find usages, and then below this will scan my code and show me every single place where I'm using that event data class. So of course the first place is the place where we just saw event data.getAll. So I'm going to delete this. Well, before I delete it, what is this code doing? This is in our display all events handler, and this is going to display a list of all of the events in our application. So this particular line of code should be passing into the model, which goes back into our view in the template to render. It should be passing a collection of all event objects that our application knows about. I can get that same collection by saying event repository.findAll. Okay, and that's it. I don't have to change anything. This will return a collection of events, and in my template, I'm going to use events as if it's a collection. So as long as those data types are compatible, which they are, I don't need to change any template code. Okay, so that's good. Let's go down to our next instance. I'm going to look at my usages pane down below. Notice that the one I just deleted now says invalid. I can hit this little green arrow on the left to rerun that scan, and then I can go to the next one. Okay, so the next one is on line 50 of my code, and this is in the process create event form handler. So this is going to be creating and saving a new event object from our form when someone submits our form. So I need to replace this line 50, which says event data.add, and this is essentially storing or saving an event object. I need to replace that with something that uses event repository. So event repository dot, and there is a save method, and I pass it my event object. What do I call it? New event. Okay, that new event will get saved into the database now instead of that in-memory collection. All right, let's go to the next instance. I'm going to rerun my usages search again. And our next one is on, let's see, line 57. This is display delete event form. This is going to display the event form that allows us to select a checkbox for events that we want to remove for our system. So here it's just rendering the form. So in other words, it's just going to put a checkbox next to every single event in our application. So again, this is just a get all, which I can, as above, I can replace with an event repository.findAll. Okay, I'll rerun my usages search. Then I'll go down below. We've got an event data.remove. And this is in our process delete event form. So it's the handler side of the method we just looked at, which rendered the form. And this method is going to take some collection of IDs, and it's going to loop over that collection. And for each ID, it's going to remove the event that has that ID. So there is a corresponding method in my event repository that I can use to do that same action. Event repository dot delete by ID. Okay. Just as a side note, there is an event repository dot delete method, but these are different. If you notice in the little context menu, if I start typing delete, the delete method takes an actual object. The delete by ID takes the ID or the primary key for that object. So just be careful. You know, in situations you might want to use, you'll need to use one or the other. They're not interchangeable. Okay. And I think that's it. Let's rerun our usages search below, and the only usage right now is just the actual declaration of our event data class. So let me go ahead and just delete that since we're not using it anymore. Okay, and now I think we're ready to test. So just to reiterate, what we've just done is we replaced all uses of our event data class, that static event class that was storing objects in an in-memory collection. We replaced them with usages of event repository, which is the interface that allows us to interact with our MySQL database. So there are two things I want to, or one thing I want to do before I start the application. I'm going to go in here and I'm going to turn on query logging. So in my application.properties file, about halfway down, this Spring JPA show SQL property, I want to set that to true, just so I can show you what's actually happening behind the scenes when we run our application. And then I'm ready to start the app. Once you have a database tied into your Spring Boot application, it'll take a few seconds longer to start up just because it's doing a bunch of extra work. It's scanning the code to look for entity classes. It's going to connect to the database. It's going to make sure that the tables are up to date, etc. There we go. We started up. So just be aware of that. Be a little patient. So let's browse to localhost 8080. And there are no event objects in my application yet. So let me go to create, and let me create a new one. And I'm just quickly using data I've used before. And so WWDC, Apple's Developer Conference, contact email, these are all required fields, and type conference. Let me create that. And that seemed to create correctly. We have data here. Let's go and look at a couple things to just see what actually happened there. One is, let's go back to the database and see if there's data in the database. So I'm going to go to my event table, and I'm going to, over the row for my event table, there's this little icon. It looks like a little grid with a little lightning bolt. It's kind of hard to see what it is there. This will just open up the query that shows you all the data from that table. So I do that, and I see I have now one row in my database, and I have the fields that I typed in. Type 0, this corresponds to the enum that we're still using to categorize our objects. You will be, in the exercises for this lesson, you will be creating a new object to represent this sort of categorization that can be stored in its own table. You'll be doing that yourself, but for now we're still using this enum. On the ID, notice that I have ID 1. My application is not setting the ID in any sense whatsoever, so this was auto-generated by MySQL. Okay, so that looks good. So I have a new object in there. Let's go to IntelliJ, and now I want to pull up my run pane a little bit and show you some of the stuff that was happening. So down below, you see these lines that were logged that start with Hibernate? These are lines that were spit out because I enabled query logging in my properties file. And so when I enable query logging, anytime my application touches the database, runs a query against the database, it will show us the query that it ran. And so this is a really cool thing to look at when you're first learning about object relational mapping. And in particular, we see that there are the last two queries look kind of what we would expect. So this third one says insert into event. Then we have the column names we want to insert, and then we have values. Okay, notice here that we actually are inserting an ID value. The two lines above are what actually pull that value out of the database. It says these two lines above say, hey, Hibernate, can you please give me an automatic ID value that's unique? And then that automatic ID value gets used in the insert statement. The last line, so these three lines were all called when, or these three queries, I should say, were all run when I submitted my form. So they were the first two lines I said retrieved an ID value, a primary key value. The third line called an insert statement on the database itself. All of that SQL is auto-generated by Hibernate, which is really, really cool. So, writing SQL queries that correspond to Java objects can quickly get very annoying and time-consuming. And Hibernate is just a phenomenal way to not have to do that. Basically, it's a universally used Java tool that allows us to focus on writing Java code, not on writing SQL queries. But it's still important to understand the SQL queries that are getting run. Occasionally, a developer will have to come in and look at those SQL queries because they think they have their code right, but they're not getting the right results. So they need to say, okay, what SQL query was actually generated by Hibernate? Let me go see what that query was, and that might tell me about where my bug is. So it's important that you can read SQL, and occasionally you'll need to write a SQL query in your code, but most of the time we'll use Hibernate to generate these queries for us. The last line, this line is select and it has some sort of syntacty stuff that's not as reasonable, but you can tell that it's selecting an object from on the far right from the event table, and it's the reason why this is hard to read is that these are just auto-generated names that Hibernate generates for us. These are not really intended to be readable, but it's selecting the columns that we want to display from the event table, and this is the query that gets executed when this view is rendered. So when we say, hey Hibernate, or hey repository, give me all the event objects, this is the query that's getting those. Okay, so let's go ahead and just do this a couple times again, just to reiterate what's going on here. Let's create another event. And the code with pride event is a meetup, so I'm going to select the other type here. And again, similarly, we see that was created. We can go back to our database again, and I can rerun this query again, and I see now that I have 2 rows, which is cool. Notice the type is a different value. Enums are stored as integers in a database. That's also how they're stored internally in the Java code. So the 0 enum type corresponds with conference, the 1 corresponds with meetup. And if we look at our IntelliJ console, we see that a bunch more SQL queries were generated there as well. Okay, so that's it. So, the steps we took, just to sort of summarize here, the steps we took across these 3 videos, the first was to set up and configure our database to connect to our Spring application. The second was to configure our persistent class to be able to be stored by Hibernate. So we created event class. We went into our event class and put an entity on there and changed some of the fields. We then created an event repository, which is necessary for us to query classes of that type out of the database. And then we went and used that event repository in our controller in this lesson video to insert and retrieve event objects from our controller. So those steps are going to be pretty common. The ones you're going to do over and over and over. The initial setup steps of most of the time just setting up your application properties is a one-time deal unless you're doing some minor updates. That's a one-time deal, but the other steps, configuring a model class to be persistent, creating a repository interface, and then using that repository interface in the controller, those steps are going to be the same steps you'll follow again and again and again as you introduce more models into your application.